also things that we can show on tour day, but it usually is as soon as you relocate to the town, you stop being a tourist and you miss out something. So it's relevant for basically everybody, and we're looking for some community tours and have like extended program to have like some party and fun next to the great talks. So next to React Amsterdam conference, we also do JavaScript conference, as that's the foundation of everything we're doing. That will be the second annual edition of the conference. With that, we're also growing. It will be this year a 2-day event. We'll do a free workshops day with around 5 different free programs that you can attend and register in various locations. And on June 1st will be the main day with lots of great speakers. We're also lucky to get Douglas Crockford as a keynote speaker, so he will be doing the opening talk, which is quite, well, we are pleased to have him in Amsterdam. I'm not sure if he was here before now in JavaScript events, but basically nobody else much do the really JavaScript-focused conference, just JavaScript, mostly hardcore. And for those who kind of observe the event scene, it's really important to be ready for that. Those are not recruiter conferences, Know that. So we don't have like a recruitment agency behind us. We don't have one company behind us. We always tend to be as open as possible. And of course, we have some discounts for. So if you're interested in JavaScript, I think you do. You can use this code. I will share it also by email and in the Meetup group. You'll get the 50% discount on the regular tickets that will be launched later on. But if you're lucky, you can still grab like 4, I think, last early ticket on Amsterdam JS. Or after the event or tomorrow morning, you can still grab those. And yeah, basically that's mostly it with the announcements. So the agenda for the rest of this evening will be 3 talks as I promised. So we'll start with a talk about D3 and React wrapper around it, done by Finn, our foreign guest who arrived just today. And then we'll have 2 more talks, rendering React on Lambda functions, which is like just the hypest of the hype you can get. And after the short break, basically we'll have a 10-minute break just for like grabbing another beer or running for a toilet. We'll have a third and closing talk from Almero about accessibility in modern SPA applications, which is relevant up until now, of course, and it's more challenging actually with SPA than with regular refresh-based websites. And I haven't placed this time the pitch session, which we had the last few events, because people are not that active. I always need to ask everybody personally to come up with the pitch. But if you still want to tell about your project, open source project or initiative, if you want to do a podcast, or you want to do another meetup on more specific things like database or anything else that is not covered on the local meetup scene, you can still reach me on the break, and if you have something to say, like 2-3 minutes, without the slides, whatever, just open the scene, just let me know, and we'll give you the mic, or without the mic because it doesn't work in this call, but it works in a live stream, and you can just share your open source projects. That's why we're doing those meetups, so people can actually reach out, get feedback, get more collaboration, and things like that. And of course, you can follow us everywhere. We share our video recordings there, upcoming events, and also some nice, interesting technical content. And that's it with the opening. Now we'll, just on the same laptop, we'll welcome Finn as our first speaker.
Can you guys hear me at the back there? Okay, so thanks for having me. It's quite an honor to be here. I've been on this journey for quite a while now, and hopefully I can share some things I learned with you guys. Um, it's going to be quite a technical talk, and I hope that's not a problem for you guys. I'm sure it's not. So I call my talk Source Without Spaghetti. So basically, how do we avoid the spaghetti code that comes with D3? And obviously we use React for that. So a bit about myself. I have a project which has been going for a few years now, which is it aims to discover, invent, and rank all the possible charts that there are. And so far I've collected over 450 types of charts, up to 3 visual variables. And we do that by combining all the possible visual cues that you have, so like angle, area, color, volume, etc. And in order to make it more accessible to people like yourselves, I wanted to let the charts be able to be used by people. So I needed to code them up. And as you can imagine, writing 450 charts with code could take several years. And there's no charting library available which has all the charts in existence. So I didn't need a charting library. I needed a graphics library. And this is a quote from the guy who wrote. He used it. The guy who wrote D3, Mike Bostock. Basically, to design an elegant charting library, we need to think of a theory of graphics, not of charts. So, starting out on my journey, I researched the available libraries that there were, and the vast majority are charting libraries, and there are only like a handful of graphics libraries, D3 being the most notable one. And while I was doing it, another one popped up called VX, which is React plus D3. And the problem with D3 is that it has an imperative API, so writing 450 charts will take several years, I guess, and you'll have lots of spaghetti. And VX, it's not animated, so I was looking for something animated that like looked nice, you know. What is actually D3 and how does it compare to React? Okay, so D3 in its essence, it has many sides to it, but in its essence is it takes abstract data and it maps it to like the visual realm. You know? So it performs the math for you, and it also can do high performance DOM animations. React, on the other hand, it declaratively controls the DOM, and as well as other environments, and it also has many other good design attributes like modularization, abstraction, etc. So when I started out building a graphics library, because I couldn't find one, I decided on several criteria that I thought would be good for a graphics library to have for making charts. One was that it should be animated, it should be high performance, and it shouldn't feel like a hack, you know. Quickly, let's take a detour. This is what I think should be the logical way to break up the chart into parts, to decouple the elements of a chart. Obviously, you have your data set, which is not part of the chart, but the chart itself, I think it should be broken up into a layout and nodes. They shouldn't be coupled together, because what that enables you to do is you can use different layouts with different nodes. Like, you could have the same layout and use different nodes, or you could use the same nodes like circles, for example, and have different layouts. And it enables you to mix and match the elements well together. So I've got some examples like you can use the same data set with different layouts. You can have the same layout using different types of nodes, like a stack with bars or a stack with areas. And basically the flow is that the input gets passed to the layout recalculates, and it maps it to the nodes in the visual plane, as you can see. So the fourth criteria was that the chart should be, the elements of the chart should be decoupled. Okay, so these are my like 4 criteria. And often when you read an article online, like how to integrate React with D3, they'll tell you only like one way to do it. You know, like this is the only way you can integrate the two, and they don't give you the possible alternatives. So what I want to do is show you like all the approaches I tried, and in the end I'll show you the one that I think is the best way for doing it. So, and I think objectively I found the best way. So first approach, the brute force approach. I'm sure most of you have come in contact with if you tried this. You basically React renders a container element and gives it a ref, and then D3 takes this container, selects it, does all the D3 sort of stuff like appending attributes, appending elements, changing the attributes, doing transitions, etc. And every time your component renders, your D3 code gets executed. So it's animated, but it's none of the other criteria. It's very slow. If you have lots of data points, it's quite a hack, and you don't decouple the elements of the chart. So I won't spend any more time on that one. The second one is very similar, but instead of rendering the D3 chart every single time your React component renders, you check that the new props coming in are different. And if they're different, you render again. And it's slightly better because you probably have to deep-check if you're working with data, you probably have to deep-check that the props have changed. And it's not very performant at all. So that's less brutal, but still pretty brutal. The third approach is there's this library called React Pro DOM. And basically what it is a JavaScript implementation of the subset of the browser DOM. And it provides just enough functionality for D3 to work with. It gives you a higher order component which passes several props to your component. One of them is connect for DOM over here. And what it does is it creates an element in the fake DOM and passes an extra prop to your component using the name that you use. So it passes that prop to your component. And what it enables you to do is this container that you create gives you a higher order D3 which passes several props to your component, whatever you want with it. One of them is connect and so on, and etc. And what it does is it creates an element in the fake DOM, gives you back some React element that you passes an extra prop to your component. If you're using the animation, you use passing that connect for DOM. And what it does is every 16 milliseconds it calls set state on the higher order component, and it kind of like thrashes the renders. It's very much a hack, and it's really not performant at all. But it is decoupled, so it's better than the previous approaches. Okay, so the next approach, I don't know if you guys have used React. basically what it does is it adds extra lifecycle hooks to the children that you wrap it in. And so like will enter, component will appear, component will leave. And what this lets you do is it lets you perform animations and mutate the DOM before the elements enter or leave. And then you call the callback and you hand the button back to React, and the React then takes over control of the DOM after that. And this approach has lots of complexity. And you're like, will enter, component will appear, you're controlling the animations and what this lets you do is it lets you perform animations. You need to check that mutate the DOM before the elements enter or leave. And then it calls the callback and not it doesn't react well. Reacts very slow. Takes over control of that. You also need to do deep checking at the node level. This approach has lots of complexity. Yeah, and so like we'll it is animated. And what this lets you do is okay. Fifth approach is static. Just rendering a static chart. So here, this is how you use it. You have your layout, you pass it the data. The data calls a render prop with enriched data. So it takes like your array of data and it adds extra stuff to it. So for example, if you're drawing a pie chart, it will add start and end angle to each data. And then it passes that to the render prop here. The children, and then map that to the nodes. So the nodes could be a circle, for example. Does that make sense? Do the layout here, P3, call the render prop, it passes it to the children. So this approach, it's much better. It's very performant. It's not a hack, you want to turn it data. You can also decouple the and then pass that to the render prop. Yeah. But it's not animated. And this is the approach that we have discussed. So they're almost there. And now I'll get to the approach that I think is the best part. So it's very similar to this previous one. It's much better. It's a layout. Like before. The only difference is that you wrap it with transition motion from React Motion or React Transition Group version 2. And what that does is it interpolates the rich data and passes it to your nodes at each tick. So you can animate the nodes basically declaratively like this. And this satisfies all the criteria. So let me just break it down. The reason it wins is because the nodes are stateless components. They can just render like a circle or a dot or anything. The layout is really carefully calculated and passed when you want. Each time new data is received. So you can animate the nodes React Motion or the other one. Declarative is the new layout data. Each tick passes the render prop. So your data comes in, it doesn't alter. Your layout calculates once, and then you do a simple interpolation of the values and pass them to the nodes, and they render stateless components. So this is the optimal place to interpolate values because of the time complexity. So I don't know if I lost you guys there, but basically, so that is the best approach. There's a link to the slideshow afterwards if you want to come back to it. So the data comes out using this approach. I will charge you layout, graph calculator, it's called number picture JS, and you do a simple interpolation. It basically takes this approach and gives you visualization primitives for constructing your own custom charts for visualization. So on the left we have shapes, and these are all very closely taken from D3. And on the right, you have the D3 layouts like pack, pie, grid, partition, etc. And there's more coming. So here's an example of how you use it. You import the components that you need from the library. You've got your SVG, which literally is just a SVG element. And you've got the pie layout, you pass the data. And these here are the accessor functions that D3 uses to get the values from the data. And just an animate flag to tell it to animate. So then the pie enriches the data with extra properties that for rendering the art, and passes SVG, which function, and each arc then renders each arc is a status component, which just renders a set of data on your and these here are the accessor functions that D3 uses to get this values of the data, and just an animate flag works on React Native. So the pie is we're not doing anything extra out of the box anymore. You just need to add. It uses component injection, so you can tell it which components to render. So you import the SVG from Expo or React Native, and you inject them here and here. And so yeah, that's the logic. The roadmap is to have better React Native support because some things are a bit funny. And then to add extras like axes and patterns, etc. Lastly, to have canvas support. I don't. Oh, I think Canvas. So the question is, what's the benefit of adding Canvas? I think it's more. The thing is,
it just interpolates like yeah, it took me about a month to write it, so it would take you a month extra time to do it, I guess. But yeah, I mean, it is pretty simple. Like the way I've written it, I have base classes. Like for shapes, I have a base class, and for layouts, and then I just configure the different layouts, and they use this base class to, to do their thing.
And then
so
how extensible is that? So if my use case is kind of slightly off the cases covered by your API, do I have some kind of escape hatches?
Well, you've got the component injection, so you can literally, it's like a layout, for example. It will just do the layout calculation and then pass that data to the component. So you can inject your own component and you can render it how you like. So it's completely extensible. Yeah. Okay, I think there's no more questions.
All right, thank you very much, Finn.
Thank you.
Let's give the mic.
Yeah.
Okay. Can you all hear me? Can we also just have everyone turn off or silence their cell phones? And there's that phone in the corner that was ringing a couple of times. I don't know if it's possible to disconnect that, but it was just
send him.
over here. All right. Should I just get started?
Yeah, sure.
Okay, cool. So welcome everyone. I'm DB. I've already put my slides up online, so if you want to check out the Meetup event, there's a link to where you can download and view the slides if you want to cheat and run ahead of this presentation. This is me. I'm a senior front-end developer at Impraise. I have a background in back-end dev as well. I've done a lot of different presentations at different conferences, so I like speaking at meetups and in other technical settings. And I'm here on behalf of my company Impraise. We're hiring. We're desperately trying to find more front-end developers. So if you're interested in the job or you're interested in what I have to say today, and you think you might want to work on it, let me know. So the basic problem that we were trying to solve when building this project was that our website sends a lot of email. And the way that our website works is we have a very spiky load on our emails. So Impraise is a system that helps companies manage performance reviews. And typically we want to send out reminders for everyone in the company to say, hey, you've got 48 hours left to submit your review. Hey, you've got 24 hours left. You've got 4 hours left. Go to the website and actually do your review, please. So what that means is every so often we go from 0 emails sent to a couple hundred or 1,000 emails sent as quickly as possible, because these are notifications and they are time sensitive. While we don't actually do the email sending ourselves, we do need to render the HTML that goes into each of these emails so that the people receiving the email sees their name and the information related to their review. And it got to the point that our backend servers were getting bogged down by so much HTML and text that they needed to render for these emails. So what was a good solution to having a spiky workload? We decided to check out AWS Lambda and see how we could harness the power of Lambda to scale up and down very, very seamlessly. The next question was, what do we actually run on Lambda? And the front-end team at our company decided, why don't we check out React? Why don't we try running React on the server side in order to render the HTML for these emails? So the nice thing about that was it's a familiar technology. We're already using it at Impraise. It's a familiar use case because basically rendering HTML is what front-end development frameworks are all about. So it's already well-tuned for this use case. And of course, because it's JavaScript, we have access to the entire NPM ecosystem, and we could pull down lots of different tools that would help us out. Also, as was mentioned earlier, this is like the hipsterest of hipster technology, so we figured, why not see just how far we can push the envelope? So we came up with this project that we're calling React Mail Merge, and it is open source. You can go on GitHub right now, check out the project, clone it, play around with it, and so on. Some people might be thinking, so what's with the name? Well, any of you who were around in the bad old days before email got to be super popular, there was a process in Microsoft Word called a mail merge where you'd link up your address book with a form template in Microsoft Word that had forms for like a first name and an address and so on, and it would link these two together and create for you a couple hundred different copies of a letter that's almost the same but has information from the address book for each person. So it's sort of like what we're trying to do here. This project is not actually delivering emails, it's just putting together the HTML to do so. Plus, it's way retro, and we've decided that everything old is apparently new again, because tech keeps on reinventing the wheel over and over and over. But that's a side conversation. Anyway, so how does this project actually work? First of all, it's more of a set of guidelines than a reusable framework. We don't really have a project that you can plug your own code into. But the way that the code as we've written it so far works is we have one Lambda function per email template. Now this means that your email templates can be as flexible or as inflexible as you want them to be. So for example, we have an email template for inviting users to our platform. We have an email template for letting them know that they've joined a group and so on. But we also have one email template for all of the different reminders that we send, whether it's a 4-hour reminder or a 24-hour or a 48-hour or 1-week reminder or whatever. We all use the same template for that. So you can be as flexible as you want. We have an API exposed so that you can invoke this template with structured data. Mail merge does data validation to make sure that the data that's being passed is exactly what's needed to render the template. And you're not missing anything important like, the name of the person who we're sending the email to. Then it renders the email templates, both HTML and text. And you can either pass it a single set of data for a single person, or you can pass an array of data for every single user that needs to receive one of these emails. Then it takes the results of that rendering and passes it along to your mail delivery service. We happen to use a company called Postmark, but you could customize this to use whatever mail delivery service you want. And it gets any errors that might occur from the process of sending the emails from the mail delivery service and logs them and returns them to our backend that's calling mail merge as well. So there were a couple of benefits that we wanted to get out of this project, like being able to deal with spiky workloads. But there were also a couple of unexpected benefits that we found along the way. And briefly, those are using Storybook for mail preview, finding out that fixing the email copy using this project was surprisingly simple, using JSON schema as documentation for our backend developers, having robust localization and internationalization support, and also being able to do continuous deployment via our CI system. So what all those means? First, let's start with Storybook. I don't know if any of you are familiar with this really handy project called Storybook, but basically what it allows you to do is to take a component that you've written or a section of your code and display it in a way that's very friendly to see and easy to modify. So in this case, we've set up Storybook with a bunch of our different email templates, and we've added in some basic information that you can use to render the information as well. So we're using this plugin called Storybook Knobs. So you can put in the base URL that you want the links to go to, the username that you want to show up in that email, and a couple of other pieces of information as well. It's really easy to change. It's really easy to instantly type in a different name, type in a different group name, and so on, and see how your email is going to look with that new information. Now, as an aside, HTML email is awful. And just because something displays properly in the latest version of Google Chrome does not mean that it's going to display properly in an ancient version of Microsoft Outlook. So you have to do more validation than just checking in Storybook, but this is a good start. Another unexpected benefit that we found was easy copy edits. You're all familiar with React. You're all familiar with the JSX syntax. Essentially, it looks more or less like HTML. And we found that people at our company who were not developers but already knew HTML were able to understand what was going on in our email templates and to very easily make copy changes. So if we found that a word was misspelled or there was some phrasing that was a little bit awkward or something like that, the product managers and product owners didn't have to wait for the developers to get started on this. They could actually make their own pull requests to the repository, and this happened multiple times, which was really cool because it meant that the developers could focus on the more difficult, deeper problems, and the people who wanted to focus more on exactly how the emails were written and how they were displayed could focus on that very easily as well. We also used JSON schema to validate the data coming in to our Lambda function. So this serves two purposes. One, it makes sure that the templates that we're using receive the data that they need in order to render properly. For example, if you have a reminder email that is supposed to remind someone about an upcoming event, but the data that gets sent to React Mail Merge doesn't have any information about that event, you're not going to be able to generate an email that's actually meaningful to send off to the user. So we use the schema validation to make sure that whatever the backend is passing is actually meaningful and has the correct structure. But in addition, we found an extra unexpected benefit here, which is that the people who were writing the backend of our software, the people who needed to actually integrate with AWS Lambda, were able to use these schema files as a form of living documentation. So they could simply read the JSON schema file and see exactly which information the Lambda function was requiring and the format that it was requiring it in. JSON schema is a pretty readable standard, and you can learn more about it on the website. We were using a library called AJV to handle the validation. It also does really nice error messages, which is important. We also do localization in our emails, because we need to be able to display information such as dates and times in a way that is robust and works for lots of different users. And if you don't think that this is important, then you've probably never had to deal with user time zones before. We have users all over the world, and all of them expect to see notifications in their native locale. It doesn't help someone who's living in Europe to see the date and time that an event is closing if that time is in the US time zones, or vice versa. Everyone wants to see information in their own local time zone. So that's why it's important to be able to have information about your time zone. Fortunately, there's a really handy library called format.js, which handles localization in React really smoothly. I was shocked to find that it was by Yahoo. I didn't know that Yahoo was still doing cool stuff these days, but apparently they are. And lastly, we're doing continuous deployment as well, because Lambda is very easy to deploy new versions of functions onto and very easy to test as well by having lots of different functions deployed in staging services as well. We're using a system called Apex to manage how we upload and deploy all of our functions. I'll be honest, I don't know all that much about how Apex works. I'm a developer. I'm not so much focused on the DevOps side. But it's something that was very easy for our DevOps people to set up And we have our system running on CI. Specifically, we use Circle CI. And every time a commit is merged to master, it just redeploys all of our Lambda functions. And it works beautifully. You can also run automated tests to make sure that the code that you're writing is safe and isn't going to break things. And we have very high test coverage. Actually, on our project, we have 100% test coverage at the moment. Now, it's not all roses. We did run into a couple of unexpected problems, and I'll go over them briefly. First of all, we discovered that backwards incompatible changes are painful. As I just mentioned, we do continuous deployment for all of our Lambda functions. So what that means is as soon as something is merged to master, it's out on production. There's not really any delay. So if we want to change the schema that we mentioned, this JSON schema that I talked about earlier, let's say we want to change the name of one of the parameters. Well, we did that a couple of weeks after launch, and then shortly discovered that all of our emails were failing. And that happened because we hadn't yet made the change to the backend that was calling our Lambda functions. So it was passing information in the old format, whereas Lambda was immediately expecting information in the new format, and so it was just throwing validation errors. So we reverted that change very quickly, and we've learned that now all changes need to be backwards compatible, at least until the backend is modified to fit with the new structure of the data as well. We also unexpectedly discovered problems in our database, problems with the data that we held in Impraise. So for example, every single one of our emails has a big highlighted call to action button. So it might be something like log in and accept your invitation, or go and submit your review to this person. We had our emails set up so that if you pass an optional invitation token parameter for each user, that was supposed to indicate that the user hasn't actually claimed their account on Impraise yet. And therefore, the call to action should say, register and submit your review. Otherwise, it should just say, submit your review. Well, we had a couple of customers contact us and ask us why they were being asked to register for their Impraise account that they'd had for a couple of months now. It turned out that the code in our backend wasn't properly deleting the invitation token, and the backend was just, merrily sending that information along to Lambda, which meant that our emails were doing exactly what they were coded to do. They were sending along the information that said, you need to register. So having this robust data validation helped us to discover problems that we didn't think we had in a very unexpected place, and we were able to solve them pretty quickly. This is not so much a problem, just sort of a lack of time issue. We haven't actually gathered performance metrics. Now, I said right at the beginning of the talk that one of the reasons why we wanted to do this is because we had a very spiky, very heavy workload. I'll be honest, I don't actually know what our workload was like, and I don't actually know how much it's improved. I presume that it has, but this is one of the things that we're looking for help on this. We know that we want to move in this direction. We know that we want to gather performance metrics and make sure that our servers and our services are running smoothly. It's just not something that we've gotten to yet. There's another problem that we've been having where we have unexpected timeouts on AWS Lambda. Most of our functions go perfectly smoothly, and all of our emails are getting sent out, but we've discovered that some of these Lambda functions, after the email gets sent out, after we send it over to Postmark, our email delivery service, just kind of hangs out, just kind of waits on Lambda until the timeout happens. Doesn't exit, just waits until Lambda kills the process. We don't know why. We're hoping that we can figure out why that's happening so that we can cut off these processes earlier, because of course, every millisecond that we spend on Lambda costs a little bit more money. So it'd be really nice to figure out what's causing these timeouts. So as you can imagine, we could use your help. As I said, this is an open source project. It's MIT licensed, so you're welcome to check out the code and to use it for yourself personally, use it for your company. The way that we made this project open is we started out writing a private repository with all of our actual emails, and we stripped out all of the private proprietary information and logos and such, and made this repository, which is open. So as a result, this repository is fairly minimal right now. We have 2 example emails that you can check out. They are based on real emails that we use at Impraise, but of course, they don't use our logos or anything like that. we would love if you could check out this project, try it out, maybe write a couple of more example email templates. We'd love to see people using different email delivery services. As I said, we're using a service called Postmark, but it probably makes sense to write a service that works with Amazon SES, which is their email delivery service. Maybe people use Mailgun, maybe people use something else. If you use something, give it a try and let us know how it works. We would love some better documentation as well. The documentation that we have is sort of copied over from our internal project and is really meant for internal use. But we would love to have more robust documentation about this is what the project is, this is why it works, this is how it works, this is how you can adapt it for your own project and your own use case. As I mentioned before, we're using Circle CI for our continuous integration system. But for this React Mail Merge project, I've also set up Travis CI just to handle things like running the tests and deploying the latest version of Storybook to our GitHub pages so that you can check out how it looks online. So we actually have both files in the repository. We have our travisci.yaml and we have our circleci.yaml. You can take a look at both of them. It would be great to have some documentation explaining what each one is for and how they work. And generally, just kick the tires and let us know if it's helpful. We built this project for ourselves, but it would be great if other people got some benefit out of it as well. So that's basically what I've got. The repository is online, as I've said. My name is DB. I work for Impraise. The slides for this presentation are also online. There's a link in the meetup description as well, and I'm happy to take questions if there are any. This guy over here.
Yes. You said you use Storybook.
Yes.
And why Storybook?
The question is, why do we use Storybook?
And not something else.
And not something else. Well, when we got started with this project, one of the other developers who was sort of putting together a prototype just to see if it'd work, tried building his own preview system for previewing these emails. And we discovered that it worked, but it didn't work nearly as nicely as using an existing open source project. So we adopted Storybook just because it was a really nice, smooth, and simple way to display one of these email template formats. Now you say, why Storybook as opposed to something else? I'll be very honest, I don't really know what the competitors to Storybook are. It seems like the best option out there, but I'd be curious to hear what the other options are.
Yeah. Well, we can.
Yeah, let's talk afterwards.
I was wondering, I don't know much about AWS Lambda, so maybe it's a stupid question, but you were talking about backwards compatibility and like having updating your Lambda functions while they and needing to update the backend. Why don't you keep the old Lambda function around for the backend if you can deploy the new Lambda functions that then can be called?
So the question is about backwards compatibility. Why don't we keep around the old Lambda function when we deploy the new one as well? There's a couple of reasons for that. The simplest one is, again, it's not really something we've had the time to investigate very deeply. Another thing is it's actually really handy to have one and only one version running in production at a time. That way you never have a question of, am I hitting the correct version of our Lambda function? I do know that the Apex framework that we're using for deployment does handle versioning. So what you're asking seems possible to me, but it also seems like it's better just to make sure that we always have the latest thing in production running appropriately. I mean, we have lots of different pieces of our system. We're moving towards a microservices style approach. And part of the idea of microservices is you should be able to upgrade components independently of each other and have the entire system continue running. So being able to run multiple versions in production and having your backend know which version it wants to talk to seems like an idea that has some merit, but not really something that we want to go for right now. Way in the back.
You mentioned the problem of sending emails. My question mostly has to do with, you also mentioned that you don't have a lot of performance metrics, but my question is mostly has to do, if you pick the alternative, which was, for example, to make a dedicated microservice for sending emails and perhaps hosting that into some sort of scaling instance, perhaps at Amazon or at Google. Do you believe that the cost would be higher towards a functional approach?
I'm not sure if I understand your question. It sounds like you're asking if we could adopt this framework for something other than sending emails. Would that be worth it? No? Okay.
If instead of going for Lambda functions,
Yeah.
you went for a dedicated microservice that does that rendering of emails and sending them.
Ah, so instead of
Do you
using
have any gut feeling what would be the cheaper solution?
instead of using something like Amazon Lambda or online functions to have, like, for example, an EC2 instance that is dedicated to doing all of this rendering for us, and also does auto scaling for you. I mean, the first thing I would ask is, that sounds totally possible, but why? I mean, the nice thing about Lambda is that it handles the scaling for you very smoothly and very easily. If we did actually set up our own EC2 instance or whatever we wanted to use, yes, we could set up auto scaling very easily and we could make sure that it's running properly, but it's more work for us as people hosting and running the service. We need to make sure that it's scaled appropriately at any given time. We need to handle things when they go down. By using a service like AWS Lambda, we can allow Amazon to handle all of the infrastructure approaches for us and just focus on the thing that we care about, which is rendering HTML. Does that answer your question? Let's you and I talk after we're done with questions.
So it sounds like you're using React just to render some static HTML on the server. So for me, it sounds like a really misuse of all the functionality that the React provides you. So why not just use the pure HTML template agents like handlebars? I'm pretty sure they will be much faster than React.
So the question is, we don't seem to be using the really powerful functional features of React. We're just using it to render simple email. Why should we use React rather than something like handlebars? And the answer to that is twofold, I suppose. The first answer is, as I mentioned, React gives you a really nice JSX syntax. Yes, you could use something like handlebars. There's a ton of different templating languages out there. But React gives us both a familiar HTML style templating and also gives us all of the power of JavaScript. So if we want to do some sort of mapping over data, or if we want to do some transformations or anything that JavaScript allows you to do, you can hook into that just like you can in any other piece of JSX. I suppose the other reason why we'd want to use React is, and that wasn't the reason I was thinking of. I had a second reason in mind, and it has, of course, vanished from my head in the process of answering the first one. That's true. Well, there's a certain amount of hype in there, but more generally to that, there is a very large ecosystem around React. As I mentioned, we're able to use tons of different NPM libraries. We're able to use Storybook. We're able to use JSON validation functions via AJV. We're able to use all sorts of different libraries that do exist right now or could exist in the future. And it seems like it's easier to hook into a well-known, well-regarded framework like React than to try to sort of build out all of these things on our own. Maybe it's not the best answer, but it's what we're using right now.
Right, sorry. Let's continue with next questions after.
Okay.
Just to keep on the schedule. So thanks a lot, David,
yeah.
For your talk. Another round.
Thanks.
So now we continue to a 10-minute break. Please be sure to take your seats again at 8:10. So grab some beer, toilets, whatever. We also have stickers laying around, so if you like Amsterdam JS React Amsterdam stickers, feel free to take them.
All right. Oh, cool. Thank you.
way.
Okay. And that can go in.
Or belt, there's a clip.
Yeah.
It's recording.
Is there a pocket? Yes, there is. There we go.
Right, so we'll slowly continue with the next talk. Basically the third talk of the evening, also the final one for today. After the talk, there will be time for finishing the beers and pizzas. So welcome Almero with
Thank you very
the
much.
third and final talk for today.
Thank you. Hi everybody, good evening and welcome to this talk on breaking the silence. Tonight we're going to look at screen readers and how they interact with our React applications. Also going to be looking at what we can do to make this interaction better. My name is Almero Steyn. As you can see, I'm a total accessibility fanatic. That's why I'm also standing here tonight telling you about it. I work for a company called Q Delft in Delft. And what you're about to see tonight are solutions that I found on real-world projects for real-world problems while building websites for the Dutch government, amongst others. You can find me on my blog or on Twitter if you have any more questions or need some information. But let's dive right in, and I think we'll start with an introduction of what exactly are we talking about now? Inclusive design, accessibility, big words. What is it about? If you haven't heard of it before, maybe let's just have a look at it. And inclusive design refers to the design of mainstream products and services that are accessible to and usable by as many people as reasonably possible. Now, when we translate this to our web applications, we are talking about web applications that are designed and built to be used by as many people as possible, regardless of how these people interact with computers and the internet in general. And of course, in order to achieve accessible design, our websites need to be accessible. And an accessible website is a website that provides its information, its actions, everything that's contained within the website to users out there, once again, regardless of how they interact with the internet. Now, this talk is not about accessibility basics. If you want to read more about it, if accessibility is new to you tonight, please visit the page on accessibility in the React docs, which I wrote last year for the React docs. It'll tell you about why accessibility is important and how do we achieve this baseline of accessibility. And a general secret is if your HTML that's rendered is good, you already have about 80% of your accessibility covered in your applications. There's the link. Go and have a read through all the links in the presentation. This is already online. I'll show you where it is later, so don't worry about writing it down. You can always go and find it. Tonight, we're specifically looking at screen readers. What is a screen reader? A screen reader is basically a piece of software that acts as a voice synthesizer that will read the screen back to a user that cannot see the screen at all or cannot see the screen well enough to interact with it. So all the text, everything on the screen is ideally read back to the user through these pieces of software. I've got the three most used screen readers on the screen here. JAWS, Job Access with Speech, that is a paid Windows screen reader used with Internet Explorer. NVDA, Non-Visual Desktop Access, which is an open source Windows screen reader that you can use. And if you have an Apple device, you already have VoiceOver hidden behind the accessibility settings that you can go and activate and experiment with. But what is it like to use a screen reader? Now, a screen reader user, to put you in their shoes, I'd like you to imagine navigating a totally dark room with a flashlight. And all you can see in this room is exactly what the flashlight is shining on at any one moment. So if you have a table of people sitting in the room and you shine the flashlight on them, you can see what the people are doing. But if I shine the flashlight away from the people, somebody gets up, silently walks away. I have no idea what he's just done. I have to go look through the room. Where is this person? Oh, and finally go and find the person if I want to know what has just happened, unless this person calls out to me. And in the same way, screen reader users experience the website. The screen reader will read back only the element that the user is currently interacting with, or the user can sequentially read through the web page to discover what is happening at the moment. And in the same way as with the dark room and the torch, if something is happening outside of the view of the screen reader, the user will be totally unaware of it. And maybe the best way that I can do this is to illustrate with a video clip. And keep in mind that this application I've created, well, hopefully we'll see it soon, but this application I've created is built with accessible HTML. So there's nothing in the HTML that keeps screen readers from seeing what's happening. But it's got some basic routing. It's a basic to-do type application. And I'd like you to notice what happens when the user navigates in the website, and try and imagine that you can only see the element that is currently being used. The element that carries focus, you'll see the focus outlines, or close your eyes and try and see if you can figure out from the language track what is happening. And with a bit of luck, okay, now it's really, okay, we're going to try this again, as it's not my computer, and maybe a Robert is around to offer some suggestions of why I can't see my video.
It should be like this, right? You shouldn't see the screen.
Yeah. Okay, also, can you refresh this for me, please?
Yeah.
There we go. We just needed a bit of magic touch. Okay, now you can see the video.
Enter. Tab, React Amsterdam demo add task page, contact link. Tab, add new task, name editor required invalid entry. Tab, description editor required invalid entry. Tab, cancel and go back link. Tab, add new task, add task button. Enter.
Okay, the video is not working tonight.
Shift tab, shift tab, shift tab, name editor required invalid entry, use JAWS key plus Alt plus R to read descriptive text. Please provide a task name, type in text.
Yeah, unfortunately.
Tab, cancel and go back link. Tab, add new task, add task button. Enter.
That is what happens when you present on somebody else's laptop. Okay, that's a bit unfortunate because you had to see what was happening there. Is there any way to get this? Sorry, this is a little bit crucial for the presentation.
So once again, what do you want to do? Play again?
You can try and play it again, but we need to see what is happening on the app.
It starts repeating again.
Yeah.
Okay. Yeah, we can just run.
Sorry about this.
Now it's frozen. Yeah, sorry about that. It's latest Apple laptops. When you use touch bar, they suddenly crash. I'll need to reboot it. You can tell a nice story again.
What would you like to hear again?
Where are you from?
Originally from South Africa. So, what got me into accessibility? I was a normal developer. Not that I'm saying I'm abnormal now or higher than everything, but I started out like everybody does, and I worked on a project, my first project for the Dutch government, and there it is important, especially if you do websites that everybody has to be able to use, accessibility is very important. And there I got introduced to accessibility, what it's all about, and immediately it made sense to me. It made sense to me that I want to create applications that's not only for me, but for everybody out there. So I started digging in deeper, and beyond just achieving that, there is this whole subculture under it, there's techniques, and it really becomes interesting to actually seeing this taking shape, because this is a totally different render to the visual render. In fact, your browser renders a DOM from your HTML, but for screen readers, they render an accessibility tree, and finding all of these features of the browser and how it exposes it really excited me.
Do you think it makes, while you're speaking about complexity of DOM, we have mobile first experience, right?
Yes.
So we have specific interfaces built for mobile devices with limited layout, and
Yes.
users use them on the go. So,
Even if it's straight on without the preview.
The same desktop application for accessibility. Maybe it should be simplified.
actually, you are quite right. There's no reason that you have to do, in most cases, there's no reason that you have to do more work to achieve accessibility. You just have to render the right HTML. And the more basic the HTML, the more straight direct translation is in terms of clear text, in terms of what's on the screen at any stage, the less work that you have to do. So yes, a basic mobile-first application that just presents its text in the right way will be a lot more accessible than a complex application will be. But we're going to give it a try again. Let's see. And it's working. Okay.
Enter. React Amsterdam demo add task page, contact link. Add new task, name edit required invalid entry. Description edit required invalid entry. Cancel and go back link. Add new task, add task button. Enter. Shift tab, name edit required invalid entry. Use JAWS key plus Alt plus R to read descriptive text. Please provide a task name, type in text. Cancel and go back link. Add new task, add task button. Enter. Windows G.
So what we have here is what one could say, a very basic application. It would be hard for me to present React features with some routing and make it more basic than I have made it there already. But we saw problems. We saw that navigation wasn't announced. I was changing whole views into and out of the page. This was not announced. The form errors were not announced. Application actions were not announced. Data was being loaded. The user was being redirected. And if you thought about that this is what you heard was the only thing you could see, even this small little application turns out to be virtually unusable to a screen reader user out there. And why is that? Routing out the box is silent. If I use React Router and I go and render components, screen readers don't know that the new component is rendered. Other important updates and messages are completely silent. Error messages on forms, the fact that data was being loaded, the fact that data was finally loaded, this is all very important visual cues. The screen reader said nothing about it. So at the end of the day, what I'm telling my screen reader users in that application is, dear user, you are not welcome. It's definitely not what I want to be able to present in my applications. So tonight we're going to look for some solutions to these problems. Now that the videos are finally working, thank you, Robert. First of all, set focus after navigation. Now, earlier in the talk on D3, we already saw some mention of refs. What I can do is a routed component, as soon as it is rendered, I can go and set focus in an element in that component. The screen readers will read out whatever text is in the current element that has the focus. In the same way that I could set focus on an element using the tab keys, like we just saw, I can, in JavaScript code, go and set focus on an element. In this case, it will be handy to set focus to my header element. Why? Because a header describes the section that I'm currently want to tell the user about. In order to set focus on it from JavaScript, I need to add a tab index of -1 to it. Otherwise, I cannot set focus to a header. Typically, form controls, things like buttons, inputs, links, they are all focusable, but any other element, if I want to focus it, I need to add a tab index of -1 to it. And then I can use the ref, which gives me the handle to the mounted element in the DOM, and imperatively I can go and set focus on it. Interestingly enough, the React docs mention do not overuse refs. Correct. But setting focus for accessibility is one of the very use cases mentioned there when you do use refs within React, and that's the reason that it exists. Okay, so we're back to a video. Now let's hope that it doesn't go the same way. And it does. This is a nightmare. So we're just going to reload it. it probably would work better in Firefox. Okay. Right. This is really a case of works on my machine. But then, yeah, I'm going to unfortunately, if you have, do you have something like Firefox installed on this? Then I'm going to give it a shot in Firefox because I definitely know that it worked in Firefox. And we'll go back to that slide. And now it's green. No, this is cursed tonight. This is as good as it's going to get.
Amsterdam demo add task page. Add new task heading level 2. Add new task. Name edit required invalid entry. Type in text. Add description edit required invalid entry. Type in text. Add cancel and go back link. Add new task. Add task button. Enter. 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 Shift tab. Shift tab. Shift tab. Cancel and go back link. Add new task. Add task button. Enter. Tasks. React Amsterdam demo tasks page. Tasks heading level 2.
Okay, so we've solved a bit of the problem. At least the user now gets to see or hear that something has happened when I navigated at any point. Because focus was set on the header, the user got some feedback. In order to get the other app updates, I want to use something called Area Live Regions. That's what I really want to get tonight through all the not working videos. Sorry again. There is a link, very long link. Once again, I'll share the slides. You can go to that link to read more about Area Live Regions. But an Area Live Region is nothing more than a region I create in my HTML, JSX, that eventually translate to HTML, that I go and decorate with a number of attributes. Important, all area attributes are valid JSX props, and it's supported by React, so you can go and use it in your JSX. Typically, a div is maybe used. The idea of an area live container is that an area live container is registered with screen readers. When the content of this container changes, screen readers will announce this to the users. So there's a couple of interesting attributes. First of all, it's handy to give it a role, to tell the screen reader what type of container it is. In this case, I used log. By the way, the other values are down here. A log role says that I'm going to be appending messages to it. Area live is the level of the messaging. Polite means that the screen reader will keep on reading what is just read before reading my message. Assertive means that I interrupt the screen reader, so I have that power as well. Don't just use assertive. Polite is usually good enough unless you really want to interrupt the user. Area relevant gives an idea of what type of changes I want the screen reader to read out. And finally, area atomic gives an idea or tells the screen reader to read either the entire content of this region or only the changed bits of the region when the content changed. So let's go and use what we've just learned, and we're going to implement an error announcer for our input. And it should be easy enough. I should be able to just go and render an area live region with some error text when the input is faulty. You also notice some other area properties, which has nothing to do with live regions, but for instance, area described by ties the error text to the input, so that screen readers also know that it's not just some text on the page, but that text refers to the input above. I had it in there because I want to show you some accessible JSX as well. Okay, this should be fine. Now I've got a green screen of death again. And we're going to see what JAWS now does to the errors. You have in your mind what the errors were. Hopefully the video.
Cancel and go back link. Add new task. Add task button. Enter. Please provide a task name. Please provide a task description. Add task button.
Okay. So the screen reader, JAWS, have now read out my form errors. Yeah, it's time to celebrate, party, we're done for the night, we can go home, or maybe not, because there are also other screen readers out there, and let's have a look what NVDA does to the same solution.
Cancel and go activated link. Add task button.
Oops. Okay, so it worked perfectly in JAWS with Internet Explorer. With NVDA, with Firefox, my live regions are still pretty silent. And why is that? The reason is that live regions need to be rendered stably before you go and change the content if you want to communicate to all screen readers out there. So let's go and fix it. And this example can easily be fixed by not rendering and swapping in and out the entire live region, but rendering the live region and only going and changing the content of this live region when I want the screen readers to announce it. But simple example, we already had some problems with it. It feels a bit fiddly, and it is. Imagine having these live regions all through your application and trying to manage, okay, when is which one rendered, and think about a component that is now just working and the user of the component decides to hide it, and all of a sudden my live region is broken. So what I actually want in my application, I have one screen reader that can read out one bit of text at a time, and a user or person that can hear one bit of speech at a time. So ideally, it would be nice to have one area live region in my application that would broadcast all these messages to screen readers. And where do I want to put it so that it's most stably rendered? I vote for right at the top of the DOM or right at the top of the component tree. If I can get it in my root component, I know that it is rendered for the lifetime of my application, and the rest of my application can just send messages to it. Wouldn't that be wonderful? If I render it further down in my component tree, I always have the chance that it will be switched in, switched out. If I have too many live regions floating around, I have a chance that the messages will override each other. Some will get swallowed by screen readers. So we want a stable region at the top of our application. We know now what we're going to be doing, so let's go and light up the dark room that we had in the second or third slide. But communicating from child right up to the top parent is not a simple task. We need React context. If we want to make something like that work now, or roll a complex Redux solution, that would do it. React broadcast, there are a number of solutions to do it, or you could just use the Area Live announcer that I've created for you, that you can pull down from NPM. It's called React Area Live. It provides you with two components, a live announcer and a live message. As long as you wrap your entire application with live announcer, you can use live message anywhere in your application. If you are changing the message prop or you are rendering it with a static message, that will be broadcast to this area live region that's rendered right at the top of your application, and it will broadcast these messages in as stable a way as, well, humanly possible, one could say, because these area live regions can be a bit fiddly. So with another green screen movie, I'm going to try and show you what happens now. We've got focus, we fixed the form errors, and now I've implemented React Area Live. Of course, if you want to roll your own context solution, be my guest. It's nice to go and play with these Area Live regions to see how they actually work, but we're now going to see our little application with focus control, with error messages being broadcast, and app updates being given to the user. And here we go.
Skip the content same page. Add tasks current link. Add task link. Enter add new task. React Amsterdam demo add task page. Add new task heading level 2. Add task page loaded. Add name edit required invalid entry. Type in text. Add description edit required invalid entry. Type in text. Add cancel and go back link. Add new task. Add task button. Enter. Please provide a task name. Please provide a task description. Shift tag. Shift tag. Shift tag. Name edit required invalid entry. Use JAWS key plus alt plus R to read descriptive text. E R require E. A E space E E N E O N. Add this descriptive R. A E A E R A N. Add cancel and go back link. Add new task. Add task button. Enter. Adding task prepare presentation. Once complete, you will be redirected React Amsterdam demo tasks page. Tasks heading level 2. Tasks page loading. Tasks loaded.
And there we have it. So what we see now, everything that that a visual user, a sighted user can see on the screen happening, a screen reader user can hear happening through the screen reader, and that is what we are trying to achieve. That is inclusive design. All our users can now experience our app at the same level, and that's what I wanted to show you tonight. So sorry once again for the technical things. Sometimes it happens, at least. Thank you for sticking through it with me. The presentation is already online there, so you can maybe go and rewatch some of the video clips without the green shade. If you want to have a look at the example app, I've got it on a branch on my GitHub repo of my React A11y patterns. You can go have a look at the application. Thank you so much. I don't know if we've got time for questions now. Otherwise, find me during the course of the night if you have any questions on this. Thanks again for your time.
Thanks a lot, Almero. We do have time for questions and beers, but not in the distance.